What makes the Platonic solids so special? Well, two things actually. One, they are the only polyhedra whose faces are exactly the same. Every face is identical to every other face. For instance, a cube is a Platonic solid because all 6 of its faces are congruent squares. 2. The same number of faces meet at its vertex. Every vertex has the same number of adjacent faces as every other vertex. For example, 3 equilateral triangles meet at its vertex of a tetrahedron. No other polyhedra satisfy both of these conditions. Consider a pentagonal prism. It satisfies the second condition because 3 faces meet at its vertex, but it violates the condition number 1 because the faces are not identical. Some are pentagons and some are rectangles. The Greeks, who were inclined to see in mathematics something of the nature of a religious truth, found this business of there being exactly the 5 Platonic solids very compelling. The philosopher Plato concluded that there must be the fundamental building blocks, the atoms of nature, and assigned to them what he believed to be the essential elements of the universe. He followed the earlier philosopher Empedocles in assigning fire to the tetrahedron, earth to the cube, air to the octahedron, and water to the icosahedron. To the dodecahedron, Plato assigned the element cosmos, reasoning that, since it was so different from the others in virtue of its pentagonal faces, it must be what the stars and planets are made of. Although this might seem naive to us, we should be careful not to smile at it too much. These were powerful ideas and led to real knowledge. As late as the 16th century, for instance, Johannes Kepler was applying a similar intuition to attempt to explain the motion of the planets. Early in his life, he concluded that the distances of the orbits which he assumed were circular were related to the Platonic solids in their proportions. Only later in his life, after his friend, the great astronomer Tycho Brahe, bequeathed to him an enormous collection of astronomical observations, did Kepler finally reason to the conclusion that this model of planetary motion was mistaken, and that in fact planets moved around the sun in ellipses, not circles. It was this discovery that led Isaac Newton, less than a century later, to formulate his law of gravity, which governs planetary motion and which ultimately gave us our modern conception of the universe. Now, take a look around you. Are you ready to apply what you've learned? Do you think you can recognize the side effects of the Platonic theory surrounding you? Can you feel the modularity